Okay.
All right. So we're
Can you pass the presentation to a screen to me so I can
sure.
probably share the
Yes.
yeah.
So, but first, let me just give an official shout out to Andrea here for helping us run a successful ONOS hackathon at IETF this week, and also providing lots of nice pictures and lots of good feedback that we can use to improve ONOS and improve our ambassador program. So that was very successful. Great. And so today we're going to talk about two things. First of all, we're going to talk about the project creation review for ACTN project. And also, Madan's going to share with us some of his ideas for, well, not ideas actually, more of an overview about new functionality available in the code base for hybrid logical clock. All right, so I'm going to start with you, Aihuaguo. I'll make you presenter. You should,
Okay.
you should be able to now see the share capability. Perfect. You can see it.
Uh, yes.
All right, the floor is all yours.
Okay. Yeah, let me minimize this one. Okay, you can see my screen, right?
Yes, we can see the title slide page.
Okay, perfect. Yeah. Okay, so I'm gonna give some brief updates of the ACTN projects since the last TST, and it is now for a creation review. So ACTM, so there are a bunch of criteria that needs to be met in this creation review. So I just listed briefly the information in this next few slides. So first of all, ACTN represents for hierarchical control of traffic engineered networks. So we put this project name as ACTN, which means abstraction and control of TE networks. And there's a project wiki, a wiki page describing the project and different components in this project. And since the last TST, it was updated with additional contents describing the scope of the project. So Aiwa, I'm the current project owner. So the scope of this project is to introduce the capability of orchestration, control, and management of a large-scale multi-domain, multi-vendor TE networks into ONOS via a hierarchical abstraction method. In this case, the scope of TE networks is defined to include both connection-oriented optical networks, OTN, with OTN and WDM technologies, as well as packet networks, which is connection-oriented, like MPLS-TP and MPLS-TE. So we are looking to create a common abstraction layer to cover both TE networks in the domain.
Great.
So this is a review of what we have put in place last time for the ACTN project scope. There are four major sub-projects that we would like to carry out in this scope. First is a implementation of standard IETF-based YANG model as used as both a northbound interface for the domain controller in this hierarchy, as well as a southbound interface from the supercontroller to the domain controller. And the business logic for the supercontroller, also in the standard is called MDSC, Multi-Domain Service Orchestrator, which implements a multi-domain, multi-vendor hierarchical SDN control, as well as virtualization and abstraction function. And this piece of work will be implemented as a set of apps running on top of the ONOS core. At the interface, we also will implement PSAP protocol extensions used as a northbound interface as well as a southbound interface with respect to different layers of controller. There will be implementation of stateful hierarchical PCE extensions, PCEP-LS extensions, as well as PCEP virtual network extension. All of them are defined and standardized in the IETF community, just like the IETF YAM model. And at the lowest level of hierarchy, we will implement a ACTN PNC controller, also known as the domain controller, which is responsible for to perform SDN control for TE traffic engineered domain networks, and also to provide an abstraction layer to the supercontroller for hierarchical control. So on the right side, it's a graphical picture showing this blocks. However, I have to point out that the picture just shows that some part, like all of the parts of the ACTN were designed in an app. However, in our last TST, there were feedback asking us to provide an analysis and some proposal to sort out whether we could, some of those common functions like topology database and topology management functions could be potentially introduced as a common logic into the ONOS core. So we did a good analysis and came up with a proposal, which I prepared in a separate slide. Maybe if we have time, we can actually discuss it here, but that's also prepared. And here are the list of contributors that we put on the wiki page from multiple parties. And the current release deliveries, schedules of deliveries, we have defined to include most of the deliveries will be in the upcoming 3 releases. So the basic function and interface capabilities will be introduced by the first 2 release, H and I release. So the logic behind those, the distribution of those functions are like that. In the upcoming H release, our effort will be focused on bringing up the topology, IETF topology northbound interface and southbound interface, as well as the topology management function and relevant TE extensions in both the core and the application that will support those topology management function in the in both the domain controller and the supercontroller. So basically the design goal is by this H release, we will be able to create this list of hierarchy of controller, and we'll be able to demonstrate the topology retrieval from each of the PNCs at the lowest level, and to see an aggregated topology view from the supercontroller using the ONOS GUI from the north. And in this part of this effort is to solidify the use of YARN-based tools like the YARN to JSON and XML encoder decoder. This is not only going to be used by this YARN util, which is a separate project, but also it will be actually called by the topology providers as well as the topology application from the northbound of the supercontroller to encode and decode relevant JSON models. And so in the I release, the logic behind the I release is we're going to introduce the capability to for tunnel provisioning, basically to be able to provision end-to-end multi-domain transport or not transport TE tunnels across multiple physical domains, multiple domain controller, and also support using the IETF YANG model for the tunnel provisioning. And also in this process, we need to introduce the basic path computation capability in order to support automatic provisioning of the tunnels. So that's the current plan for the I release. And going forward in the J release early next year, we're gonna make the topology, both the topology and tunnel function more complete. For example, for the tunnel control function, initially we will be supporting basic functions like just tunnel provisioning without any constraints. But in the J release, we'll be supporting constraint-based tunnel control. We'll be able to ask a user to specify explicit constraints like the number of the exact hops in the topology to use, and the exact resources, and also constraints like diversity, SRG, and other constraints. And we'll also demonstrate the function for tunnel protection and restoration across multiple domains. And based on those capabilities, we'll also introduce the Virtual Network Manager application, which allows the user to configure and build a virtual network from the northbound, from the user's point of view, which is implemented as a set of abstract tunnels and topologies supported by the supercontroller.
Okay.
Okay, so this is the current release deliveries. And what we have done since our last TST, as mentioned, we updated the wiki page to reflect the updated project scope and design. And also we socialized ACTN with the community and other existing projects, as well as projects that are currently outside of ONOS but has some relevance to the scope of work. The two primary projects that we analyzed and socialized is the ICONA project. While talking with the ICONA folks, they also introduced this Aquino project, which is an EU project, but has some consideration for IP optical integration. And actually, from what the current analysis, it looks like, so ICONA is focused as a southbound provider, which currently focuses on the layer 2, layer 3 network. It actually complements what we are doing in ACTN, which is TE-based. However, we all agree that the common abstraction that both ACTN will introduce into ONOS could be actually shared and could be reused between these two projects if ICONA eventually will consider layer 0 and layer 1 networks and extended the support as a southbound provider to those network types. And also, we did a good analysis of the virtual network manager that ACTN introduces, and also the current virtual network subsystem in the ONOS implementation. Actually, we have also a separate slides describing the analysis. And we also address the concerns to have a common abstraction for TE operation and will have made a TE extension design that focuses on bringing this capability into the core, so which is ready for review. And we have established 2 stories in GitHub: the ETF YAN MBI SPI and the ACTN MDSC controller. And we have kicked off some implementation offline and actually have started to implemented some part of the basic functions of the ACTN modules, like the YARN to JSON XML encoder decoder and its integration with the YMS. And we also started implementing RESTconf protocol client and server implementation, which is a essential part of the northbound and southbound interface which the ACTN MDSC and domain controller is relying on. And also the design for an IETF-based TE provider in the southbound interface layer is also under design, and the same for the TE topology management module, as well as the TE tunnel management. However, I have to point out that those are preliminary designs, and as I mentioned, we have some consideration for a core TE extensions. However, this will need to be discussed and probably needs to be approved by the TST to move forward. But that said, we are still we have kicked off the design based on those assumptions, and hopefully this will get agreed upon really soon.
Okay, so you were talking, you were mentioning in a separate discussion, in a separate conversation over email, that you would like to set up a separate meeting for reviewing some of these things. I presume these are the things that you wanted to talk about, right?
Yes.
Yeah. So when we can probably schedule it for next week or for a week after that, if you want.
Okay. Yeah, that would be fine. I mean, I have the materials already ready, so we can probably find a good time to talk about it.
Okay.
Okay. Yeah. So that's the material that I have. I guess Bill sent the email that Bill sent actually has a checklist. So Thomas, do you think that we want to go back to the checklist and
back to presentation rights here? I think.
Yes. Yeah.
You can see my screen again, right?
Yes.
Okay. So I mean, clearly, I mean, we have the project scope, resources committed. So I think we have these things are all taken care of, right?
Yes.
The contributors identified, that's taken care of. I think the IP policy in terms of intellectual properties rights, right? So that
it's covered by Apache.
Yeah. I think initial committers, reviewers named, those are taken care of. Those were on the slide. So
yeah,
I think I mean, this is Achino and Alcona. We've already contacted them and at least assessed potential collaborations here. This is taken care of. I think it's all good to go as far as I'm concerned.
Yeah.
Any objections?
All the TST members agree to that?
Yep.
Yep.
Fun. All right, let's go.
Okay.
Yeah, thanks for summarizing all the information.
Yeah, it was nice and clean.
Yeah, I have a question. When I see the slides, it looks at the second layer, it can support multiple controller from different vendors.
Correct. Yes.
What is it doing by different vendors? ONOS is one of the controller?
Yes,
Yeah.
actually used as to establish a hierarchy between ONOS and ODO or other kind of controllers
Okay, I just
that
want to,
support the same IETF standard.
I see. I just want to confirm the point. Okay. Thank you.
Yeah, yeah. Although in our best wishes, there we hope that it's all ONOS based, right?
Oh, we do too, but I mean the point is that you don't want to make that assumption, right? All right. I mean, so that looks good.
Okay.
And so,
So
what I would suggest next would be to schedule basically a series of reviews for some of the pending questions that you have about some of the existing approaches that you have and your analyses of the Icona Achino, as well as the analyses of integrating into the existing uh, subsystems or potential extensions to other subsystems. Oh, we lost audio.
Hello?
yes.
Are you there? Okay. It looked like we were losing audio here. It looked like we were losing audio.
Yeah, I can hear you clearly, but I don't know. Yeah, it's good for me.
Okay, good. So,
Yeah, thanks TST. Can I assume that according to the project life cycle, will this project go into the next stage, which is the incubation, or?
Correct.
Okay, just to make sure, yeah.
okay. I'll put it in the minutes. Yep. So, thank you, Aiwa.
Yeah, sure. Thank you.
I'll leave it in your court to schedule to figure out which meetings, which topics you need to discuss first, and schedule the appropriate, TST meetings with me and with.
Sure. So my other question is, I believe that the review for our proposal for core TE extension, I suppose this will be needs to be carried like sooner rather than later, because the implementation and design is depending on whether it is accepted by TST or not, and the concerns that needs to be addressed. Right. So we have actually designed a few scenarios and listed the pros and cons. So hopefully this will be can be finalized soon, and then we can continue with the focus on the development.
Yeah. So if you were to look at the next week. There's 2 items on the list in the morning, but what we might need to do is we might need to schedule a one-off meeting, and if not, then we carry this into second week of basically second week of first week of August.
Thomas said, so far is we are also talk about the virtual network managers, VN managers, right?
Mm-hmm.
So you have meetings on the 26th to talk about the proposals about the virtual network.
Yeah, that's just
do you, based on your best knowledge, so the VN manager here, tunnel managers, and yours is anything related or separate?
So I would hope that they would be related, but the scope of the exercise, the goal of the meeting on the 26th is to just have a design review of the existing approach to the virtual networking.
Okay.
And as part of that, we will discuss front-end and back-end architecture, and then hopefully the front-end architecture is applicable towards those abstractions and capabilities provided by the virtual networks here can be used to carry the virtual network aspects of the ACTN.
Yeah, I think if that is the case, probably the Aihua's update could be earlier than your 26 meetings, right? Otherwise, you lack of the knowledge and the information from the ACTN project side. So.
Yeah, actually, I have some similar thoughts with Patrick. I was wondering, if we could have schedule some discussion like sometime say early next week without. So basically, I understand that we need to go for the TST, but before that, we could probably, depending on the convenient time that TST would have, maybe you can consider about some offline discussion or technical discussion just to make sure that this proposal will have some light or have some favorite consideration by the TST.
Yeah, I'm just trying to figure out in terms of time. It may be difficult because there's still some preparation work that needs to happen for next week, not only for the design review but also for other events that week, right? Because we have the core summit, and so my suggestion would be if you can attend the virtual network design review, and certainly bring up any requirements or missing capabilities then, and then we can discuss. Separately in a separate meeting, whether it's a TST or whether it's one of the on-demand meetings that we set up.
Okay.
The proposal that's more centered around your T extensions.
Yeah. I think that at least the Aihuaguo you need to make a summary about the VN analysis and the implementations and our thought on how to implement and the modifications for the tunnels, and send that ones to Thomas and the TST members or the wider audience to be before the 26th. Okay, so the 26th they already start the talk about.
Well, so I mean, it's going to be just a design. It's going to be a design review, and it's going to be a point of discussion. And I mean, this is just to familiarize. The goal of this is to familiarize people with the approach that we did.
Okay.
And also the ability to provide feedback. I mean, the virtual subsystem is not, even though it has code and existing design in place, it's not necessarily frozen.
Yeah. Okay.
So I would not necessarily. I'm not sure even if you were to send us the information that we would necessarily have time to react to it in order to, we're not going to be changing the design. We're going to be at least not changing the design between here and then. The idea is to talk about the existing design next Tuesday. It is what it is. And then depending on feedback and other requirements, we may talk about how to further evolve it from that point onward.
Okay.
I would treat it that way. We're not going to be redesigning our virtual network subsystem in response to any feedback between now and then.
Our thinking is if Aihuaguo prepare the document and send to the teams earlier,
sure.
So they could save some time in the meeting.
So then this is fine. So you certainly for that purpose it's perfectly fine. I just want to make sure that the expectations are clear.
Okay.
Or you can just bring the set of requirements essentially, or bring that documented meeting so that during meeting as the discussions and questions come up, or we can talk about any relationships. Okay.
Okay.
Hey, sorry, Thomas and Jessica and Patrick. I had some break on my audio, so I have to reconnect. But I guess I missed some of your conversation.
Actually, I can talk.
Quick check. So
don't worry.
Yeah. Patrick will catch you up. Okay.
Yeah.
So thank you. All right. I think with that we can probably move to the next item.
Sure.
Madan, do you wanna? Are you having a go meeting or not?
Slides. Sorry.
I think it's if you want me to give you. I think I've updated the one calendar. Okay. No, I'm not muted. So if you, I don't think you need to connect through video. You just need to. Screen.
Sorry. Excuse me.
Your audio is not connected, right? Okay, I think it should be able to go. There might be just a transient.
Yep, sorry.
I'm 1 second.
Can you turn down your volume? Sorry.
Actually, you should not.
Or just tell your GoToMeeting you're on a phone call.
Yeah. Mute yourself. Mute yourself also. And when you're and you mute. There we go. You're good to go. Or switch your phone. I think it's good now.
Okay, so last week I briefly mentioned about a new feature that we have as part of the core, which is what it supports is an ability to get a timestamp. And the idea is that when you want to order events, any events, um, one way we do it is, we basically call system.get current time milliseconds. You get back a 64-bit long, and then you associate your event with that number. So the idea is that subsequently, if there's another event and if you get a new timestamp, you can look at these numbers and then you can order these two events. This has various applications. Again, a lot of what we do is event based, and at various times there is a need to compare whether certain events happen before some other event. One of the most recent use case that motivated work in this direction is in Kafka integration. There is a need to publish events that are generated uh, by various applications, by various core services. And when we are doing this in a cluster setup, there is a need for us to make sure events can be published even when certain nodes are failing. The way we wanted to approach that problem is each node will keep track of the events that are published by the core, and one of the nodes will have the responsibility to do the external publishing of those events. But for them to correlate which events have been published and which events have not been, there was a need to have a unique event identifier. Since there is already a timestamp field in each event, uh, I wanted to see if that is something that we can leverage to do that. But the problem that we have right now with the timestamp in the event object is that timestamp is generated on each node independent of each other. So, for example, every node would call system.get current time milliseconds. So, in fact, even if you are referring to the same device event, depending on which node you look at, you will actually have a different timestamp value. So that is not very useful if you are trying to correlate, events to make sure events have been published once and only once. So that was the problem that sort of motivated looking into this, and that is when I looked at this concept of hybrid logical time, which actually provides some nice properties, and that is what I wanted to talk about today. So just a brief background on some things. These are things that are well known in the context of distributed systems, or even in general when you're trying to order various events. So I just wanted to provide a brief background of some concepts of timing in distributed systems, and that is where logical time comes in. People might also know about this as Lamport time. It is, again, this is based on a paper that was written in the 1970s. One of the seminal papers in distributed systems. The problem that you're trying to solve is you're trying to order events that happen in a distributed system, right? The events can be anything. An example could be, um, you write a message to a local log file. That could be an event. It could be anything uh, that is distinct. Sending of a message to another node could be an event. Receiving of a message could be an event. Um, the idea is that you want to order these events so that you can reason about what happened before what other event. And logical time provides you a mechanism to do that. Um, and the way it is implemented is, think of every node carrying a clock, right? And this clock is, nothing but a simple counter. Whenever an event occurs, again, this event is scoped to that local node. It increments the counter. So think of it as, every node has a counter. Again, going back to relativity and so on, everyone has a clock. Everyone has their own notion of a clock. Depending on how things are happening at that node, the clock advances. Right? Some node could be doing a lot of work, getting a lot of messages. Its clock advances faster than the other. But the idea is that when two of these worlds intersect, meaning like say node A sends a message to node B, they need to synchronize their clocks. The way they do it is whenever a message is sent by the sender, it will include its counter value, its timestamp value, and then sends the message out. And when a node receives the message, it takes the timestamp value in that message, and then it updates its counter to reflect the fact that it has now known about an event which happened in the past. So keep in mind that receiving an event should happen after the event has been sent out. So to capture the fact that those two events have a particular order, the way the receiver increments its timestamp is to pick the maximum of its local counter value and the counter value of the sender, and then increment it by one. So it gives you this property where if event A happened before event B, then the corresponding timestamps for those two events have a particular order, right? But if two events happened and they never really intersected and they happened in their own worlds, you cannot really reason about their timestamp values. So that's the basic property of this system. And the other thing that it does not give you, while it will let you order these things, it doesn't actually capture causality. What I mean by causality here is looking at two timestamps, you cannot tell if this particular event caused this other event. Meaning, if it, so for example, uh, this happens a lot when you read a value and then you update that value based on what you read. If you want to capture that detail, then just using a simple counter does not give you that property. Think of it as like, this is just a simple scalar. It has no notion of like, what happened or which other event caused me to do this action. That is where actually vector clocks are useful. I'm not going to go into the details of vector clocks here, but that is one of the limitations of a logical clock. It doesn't capture that information because it only has like one dimension to it. The other thing that we are all familiar with is the notion of a physical time. This is if you're running a process, calling or looking up the local system time is what this is. But we all know that you cannot synchronize clocks in a perfect manner. So there is always going to be an error bound on how good the synchronization is going to be, and the standard protocol for doing synchronization is NTP. And depending on how the network conditions are, worst case, your uncertainty bound can be of the order of 100 milliseconds.
Yeah.
So even if your clock says that the time is X, the real time, whatever that is, could be anywhere between like X plus or minus 50 milliseconds. Again, I'm talking about worst case scenario here. For example, in a data center setting, this error bound is actually few microseconds. But the idea is that you cannot rely on these timer values if you are like if you want strict correctness. The other shortcoming of a physical time is if you have a priori knowledge of what this error bound is, if two uncertainty intervals for two timestamp values overlap, then you cannot uh, order them. While in a logical time, you can actually look at the value and then say that this happened before the other one. The same is not true with a physical time. Um, So the other disadvantage for a logical time, which I did not mention and which is important, is that it just gives you a counter. It's just a number, but it has no relation to a physical time. So, for example, to a physical time. Sorry, that's not expected. Uh, so if you build a system that is purely using logical time to capture ordering information, in real world setting, when you want to debug something, I want to you encountered a problem at time X. Again, time here is a physical time. You want to see where the system was at that time. So given the fact that logical time has no relation to physical time, usually it becomes very hard to uh, do that correlation, which is again very important for debugging these kind of systems. So the goal is to come up with some notion which actually captures the good properties of logical clocks as well as physical time, right? Physical time is what everyone understands. Logical time has this nice property that it actually captures ordering information. So we want to combine these two and get one implementation of this, which gives us a value which is as close as possible to the physical time, but which also captures causality information like a logical time. So before I go to that, I just wanted to briefly touch upon this other. I think it's going to take some time to change the slide. Yeah.
Whoop.
So in 2012, Google wrote this paper on a system called Spanner, which is their globally distributed, strongly consistent key value store. One of the interesting properties that Spanner provides is this notion of external consistency. Uh, to give you an intuitive understanding of what external consistency means, typically when you do a write in a distributed system and you do a subsequent read, the expectation is that if the read follows the write, then you you will get the value that was updated. Um and what this particular system guarantees is that this is going to be, or this property should hold at a global scale. So even if you write an update in North America, and then someone in Europe, if you tell your friend that I just finished my update, and someone in Europe looks up that value, they should basically see the current state of the system as it happened. So for that, they had to actually solve some interesting problems with respect to synchronization and timing. And the way they approach this problem is they actually try to solve clock synchronization at a granularity which is much finer than what NTP can provide. And they do this by relying on a combination of atomic clocks and GPS receivers in their data centers, which gives them clock uncertainty, which is of the order of less than 10 milliseconds. And it is, I mean, one of the interesting things why they use multiple of these time sources is they talk about the fact that all of these things can fail, and the reason why they have two of these or two different systems is that the failure modes of atomic clocks are different from the failure modes of GPS clocks. So when you're trying to build things like this, you don't want to have correlated failures. So that gives you, at an aggregate, better fault tolerance for things like this. So these are, principles that apply in various settings. It's interesting to hear them talk about, how they use these things in tackling this particular problem. So again, very briefly, TrueTime is basically an API. It has a method called give me the current value. Typically, we are used to getting back a single value, but what they are saying is that there is always a notion of uncertainty with that value. What we can guarantee is that the value that you are going to get will have two definite lower and higher bounds. So it is guaranteed that the real time is always going to be within those bounds. And they use those bonds to make sure when you do commits, they can appropriately delay the commit time so that a subsequent read will be able to see the current, the most recently updated value. So I'm just briefly mentioning this because this is also a problem related to time that they had to solve to do this kind of things in the distributed database. Distributed database. Um, so finally, this is the feature that we currently have, and what this gives us is it combines the advantages of logical time and physical time, as I briefly mentioned earlier, and it provides the same invariants that we were getting with logical time. Meaning, if you have two events and one of them happened before the other one, the corresponding hybrid logical times will have a definite order with them. Again, this is not something that you can get with physical clocks because of clock uncertainty, but that is something that you get it here because that is what we want to support. The other important property, as I mentioned, is the value of hybrid logical time is going to be as close as possible to the physical time. So there is an error bound within which, again, that depends on NTP, synchronization intervals, and so on. But the idea is that, you can actually take this time and, write it to a log, and then that gives you, subsequently, it makes it easier to debug things later. And also, just like physical time, what you get back when you call this API is basically a 64-bit long. Uh, you know, Instead of using system.currenttime milliseconds, you can use this value, and that is as good as um, relying on the system clock, and in some cases better than that. So just to briefly an overview of what an NTP timestamp format looks like. So we get back a 64-bit number, but that number is actually split into two parts. The first 32 bits is actually the number of seconds that have passed since the start of the epoch, and in this case, the start of the epoch is January 1st, 1900. So that gives us time till 2036 when this rolls over. So that is when it actually becomes zero. But the next 32 bits is the fraction seconds within a given second. So what the way HLT is implemented is instead of a single value, what we now have is a tuple. This has actually a lot of similarities with how we have done our logical timestamps for topology tracking. But again, most of these logical timestamps have this notion of a physical component and a logical counter component. So it is actually very similar to that. The intuition here is that if you have a set of nodes, obviously everyone have their own physical clock. The L value is going to be the maximum physical time value. Here, physical time is the NTP timestamp component that a node has seen. So as nodes talk to each other and as they exchange messages, every message is going to be tagged with the timestamp that the sender has. And as I discover new L values, I'm going to increment my local L value to reflect the highest physical time value that I have observed anywhere in the system. And when I see a message, when I see two events with the same L value, and if I know that one is before or after the other one, like say for example, if I receive a message and if the message timestamp has a L value which is same as my current L value, and also the same C value, that actually forces me to increment the C value. So the algorithm is actually pretty straightforward. When you want to send an event, initially both L and C are set to 0. But when you want to send an event, you pick your local physical time and take the max of your current L value and the physical time value, and then include that in the timestamp. And on the receiver side, the L value is set to the maximum of the current L value, the current physical time, and also the physical time or the L value in the message, incoming message. So the set of properties that, and this is actually all that is, right? So just by sending and receiving messages, you keep updating the L and C values to reflect what you have seen locally as well as what other nodes have seen. So this gives us the ability to keep track of the highest physical time that has been observed anywhere in the system, and within the same physical time, keep track of the logical increments of events that have been observed. So using the combination of L and C gives you the true timestamp value. And the way we use this L and C is that, again, within the 64 bits, the first 48 bits are used for the L, 48 bits are, and the next 16 bits represent basically the C value. And given that the max a C value can grow here is 2 power 16, that is more than sufficient, because it actually, you know, the maximum you can only hit when, you know, the time has not incremented in the meantime. So the combination of this actually gives you an ability to represent a wide range of time values, and also, you know, make sure even if one of the node is running behind, you know, it gives you uh, an ability to make sure the 64-bit value is sufficient to capture, you know, the local time as well as the increments that you're seeing in the meantime. So again, what does this mean if you're writing an application or if you're writing code in ONOS? So there is a service called Hybrid Logical Clock Service that you can now use to get this particular value. So calling clock service.now gives you a timestamp value. The idea is that in place of using system.current-time milliseconds, this is what you use, and what you get back is closer to the value that you have.
Madan,
Yeah.
we use the HLT, not NTP, because it can represent a bigger range of values, numbers. So the
Not necessarily a bigger range, but um,
bigger
the,
range is one advantage of the
so they're both 64-bit values,
yes.
right? The benefit is that with HLT,
Yes.
you also get ordering information. Meaning, you can actually take two HLT values, and then, if you have two events and then each event has a corresponding HLT value, you can use those to order those events.
Okay. I know in OpenStack they use NTP tab.
Correct. So this actually is on top of that, and but also avoid some of the problems in NTP with respect to clock drift and so on. So, so again, a couple of immediate applications of this that we will have is all the application events that ONOS generates. The time field in those application events will be using HLT. So that is one of the first things, and in fact, there is a code review that will be in Gerrit shortly. One of the things that we'll probably tackle in the, I think I lost connection. But it's back again. Yeah, it's back.
Various connection issues.
Yeah. The other area where we will be using this is to generate a commit timestamp for distributed transactions. So again, this will be useful when. So right now we have this notion of a transaction which we use heavily when we do resource reservations and so on. The plan is for us to use the HLT timestamp value as a commit timestamp in those transactions, so we can actually serialize, different transactions appropriately.
So there's a question.
Yeah.
Someone's asking if there's a potential issue with the delay between fetching the clock service using the now method and then posting the event. I don't think there should be, really, right?
Yeah.
It's just causality. I mean, it's just, you want to just make sure one precedes the other.
Right. So the clock service is a single time. So when you are getting an event, when you say clock service.now, I mean, it is literally reading off of those local values.
Yeah.
So there is no fetching of timestamp.
Yeah, and essentially, well, the birth of the event is with essentially the creation, not necessarily posting it. Right?
Exactly.
And so it's essentially now anchored at the time at which you call now.
Yeah.
So but then I'm wondering if the application is this, the use case is this. I have external applications running basically off platform, Okay, I take the event from a different the instance, right? All these are instance event is not go across, right? It's just from the device instance go directly to to my applications. So in such case, do you think I need to implement the receiver side mechanism in my applications in order to synchronize and keep all these event orders?
Not not required. We don't expect clients to be following the same protocol. This is purely between instances in the ONOS cluster.
How can I get okay? My applications get the event in order based on the mechanism.
Because the ONOS will be so. Again, the specific implementation that we will be using to publish events to off-platform applications is Kafka, and Kafka already provides ordering guarantees because Kafka is based on a log. So the order in which you publish is basically the order in which clients will receive those events. So there is no risk of events getting reordered.
Okay, so the timestamp is only used within the clusters, right?
Correct.
Okay, once of the platforms you remove the other ones, use the Kafka's timestamp to.
No. So
No?
even every event will have a timestamp, right? The advantage of that is, as I said, this timestamp that we put there, even though it is generated using this new clock service that we have, the guarantee it provides is that the timestamp is close to real time, as in close to physical time. Okay.
It's my concern. So now we can deploy the instance into the different time zones, right? For example, this across the boundaries. So the time zones is happening in the Korea's network. So they will try to deploy that case, right?
Physical time is in UTC time, right?
Yeah, physical time is in UTC time. Whatever.
Okay, but you see they have 100 millisecond difference, right?
Right.
So the worst case.
So
in order to solve that, you introduce this.
No, this is not. This is not to solve the HTTP. Like this is not to solve the NTP drift.
Okay. I think I probably. But
It's to mask.
I wanted to ask one question, but maybe.
So my concern was if my application is running the off platform.
Yeah.
So if I still use these ones to generate the timestamp, when the timestamp received by my applications, what I see, what?
Yes.
That's my question.
You are so to clarify, we are not trying to solve clock synchronization.
Okay.
It's a physically hard problem to solve. I mean, as I said, the Google solution is actually based on having like specialized infrastructure in the data centers, so that they can strictly synchronize clocks on all the machines.
Okay.
And they very aggressively monitor which nodes are drifting. And if they drift more than like say 10 milliseconds, they actually take the node out of service.
Okay.
So that is a hard problem to solve, and even Google can only solve it to within 10 milliseconds.
Okay.
In their data centers, this is.
Okay.
Okay, that is not what we are trying to solve here.
Okay.
Given the sort of limitations of NTP and clock synchronization, can we have an approach which still lets us capture causality and ordering in a distributed system? Right. So as nodes talk to each other, as they exchange messages, if they just use system.current time milliseconds, which is the physical clock, that doesn't let you capture some of this information.
Okay.
This attempts to fix that problem.
Okay.
So and again, most of the time, I think if you're writing an application, you will not have to worry about this. This is mostly for core events and things like that. So if you're going to add a feature which is probably going to be a core feature or making any changes in the core, that is when you might want to concern about this. But most applications don't have to worry about this.
Okay. Let me think. If the consumer is the applications, how can I use this timestamps? Okay, that was the question. Let me think about this one.
Okay.
If I have more questions, I'll get back to you. Okay.
So if you're just consuming events, you can just use this timestamp like a normal system timestamp.
And it is also going to be very close to the system time. So Yeah, I think that is all I have. Yeah.
Cool.
Yeah.
No problem. This is we allocate usually sometimes.
Okay.
This is really useful. Thanks for the overview. So I guess the recommendation would be just to start using this as much as possible.
Just start using this as much as possible.
Especially about and
I don't
especially in distributed context.
Yeah, there are not a lot of cases where people actually have to assign a timestamp to the event. The one case is our events, which have a time value in it, so it makes sense over there. But most of the time, we use system.currentime milliseconds to actually capture like time delta between two events. Right there, it is there is no need for that. Right.
Should another thing is that you keep the counters in local, right? Local counters update the plus and all the things. When you do this, I know the now the spin locks we can guarantee the atomic operations. So do you see any performance impact every single times because you need the update the counters, right? So the concurrencies.
No, I mean
No?
atomic longs are like fairly fast.
Okay.
I don't think. Yeah.
Okay.
No.
Okay. Original timestamp is read only. It's a read only, but now here is so you need update.
Yeah.
So,
It's a good question, but
okay.
for the amount of concurrency that we have in our system, that's not an issue at all.
Okay.
I can imagine if you are doing like say millions of operations per second, then you might want to do it. But we probably query this once every, and the message rate, incoming message rate and outgoing message rate is fairly low.
So the original authors when they do the experiment, they already collect the stats.
Yeah. So this is
okay.
Yeah.
Cool. Okay. All right.
Oh, thank you, Madan. Yeah. Thanks, everybody. That concludes the meeting for this week. We'll talk to you next week. Bye.